Bismillahirrahmanirrahim. Welcome to MIT. Today we are going to learn integration. In the previous video, we learned how to differentiate the functions, and today this is the turn of learning how to integrate a function. Initially, I can explain the difference between differentiation and integration in brief. I have written some words in favor of the difference. Let's see what are these. Simple difference. I have written over here that simple difference between derivative and integrand. In derivative, in derivative, we multiply by exponent. You may remember that in case of differentiation, we have multiplied the exponent by the coefficient, and we increase the exponent by 1. Always the exponent was increased by 1. So two differences, I mean 2 points in derivative, or and everything is about exponent. Remember, exponent is the key role player, actually major role player in differentiation and integration. It is exponent. So exponent is reduced. First exponent multiplies the coefficient, and then the exponent is reduced by 1. This was happened in derivative. In case of integration, for your kind information, I would like to tell integration is actually anti-derivatives. That means opposite to differentiation. So integration is anti-derivative. That means the opposite concept is applied. In case of derivative, we have done multiplication, whereas for integration we will divide by the exponent, but exponent is the key point. So in derivative we have multiplied by the exponent, and in integration we will divide by the exponents. After that, we can compare. In case of derivative, we have subtracted the exponent by 1. The exponent was reduced by 1. In case of integration, the exponent will be increased by 1. So it's actually anti-derivatives, opposite to differentiation. In differentiation we have multiplied by the exponent. In integration we are dividing by exponent. In differentiation we have reduced the exponent by 1, and in case of integration we will increase the exponent by 1. Okay, then let's see an example here. This is an example. Derivative of 5x cube. Okay, derivative of 5x cube is equal to, I have done it just at the below. What have we done in case of derivative? We have multiplied this exponent by the coefficient, and 3 5s are 15. Look, after multiplication it has become 3 5s are 15. Then the exponent was 3, which has been reduced to 2. So multiplication and reduction of the exponents in case of derivative. What we will do in case of integration, we will divide. First we will increase the exponent is given 3. If we add up by 1, it is going to be 4. So remember, first of all, in case of integration, the exponent will be increased by 1. If we increase the given exponent 3, it is going to be 4. Then the second concept is we divide by the exponent. So here there was 5. This 5 has been divided by the exponent 4. Then what has happened to the exponent? Exponent was given as 3, but it will be 4. That means exponent will be increased by 1, and the same exponent will divide the coefficient. And next, last of all, we can write plus c for constant number. So let's start. I think it will be more clarified when we solve the questions practically. The first question we have chosen is from paper. First question belongs to paper 0606 0606/11. That means add maths. Let's see. the question number 1. Already I have told that this question belongs to paper 0606/1 and the question number 6. Question number 6 says, that integrate 2 over 2x minus 3 minus 3 over 3x minus 5 whole squared. As you have already come to know, it's all about exponents. So we will isolate them exponentially. Well, first one we can remain here. Exponent is how much? Look, in the first denominator or function, exponent is 1. Here exponent is 1. So we don't do anything if we find exponent as 1 in case of any function. If exponent is 1 of any function, we leave it unchanged. So we are not doing anything to this. Let it remain unchanged. Let me show you this in an elaborated format. The question is, let me write just beside this. The question is 2 over 2x minus 3. 2 over 2 over 2x minus 3, and our exponent is actually 1. Okay. So how to do this? It's actually these two. This 2 is unnecessary to be written. Then what will we do? We will write the function always in terms of exponent. And as this is denominator, exponent is negative. So it is going to be, what have we learned? First of all, we will come to know that if the exponent is negative 1, that is actually ln function. So it is going to be 2 ln twice x minus 3, and degree is 1. We don't look at the exponent is in case of if exponent is negative 1. So remember, in case of exponent of negative exponent, it is actually log. If exponent is negative 1, then it is log. Then the inner function should be integrated. Inside the inner function there is 2. So if we differentiate this 2x, it will be 2. D over dx of 2x is equal to 2, we know. So after difference, so inner function, look, inner function should be differentiated. After differentiation, that derivative will divide. So there are two clue words. One is exponent will be increased, and another one is the increased exponent will divide the coefficient. So we have divided this coefficient by 2. And if exponent is negative 1, this is exceptional case. Remember, if exponent is negative 1, that is actually ln function. So we have written that 2x minus 3 raised to negative 1 means ln function, same function, and there will be no more exponent. In this case, it's ln 2x minus 3. Then the inner function should be differentiated. We have differentiated this 2x. Derivative of 2x is actually 2. So we have divided this, the given coefficient, by 2. So two clue words. One is about exponents, and the coefficient will be divided by that exponents or derivative. So remember, in the previous differentiation class, we have come to know that derivative is coefficient is multiplied by the exponent, but here we have divided by the exponent. And if the exponent is negative 1, it is actually ln function. That is, whenever exponent is negative 1, that will be the integrand of that function will be log. So we have written ln 2x minus 3. Then the inner function, remember, always the inner function will be, the inner side of the function will be differentiated. After differentiation, that will divide this. So ultimately, what are we going to get? 2 2's. If 2 divides 2, it is going to be 1. And ln 2x minus 3, there should be no exponent at all. So this is exceptional case. In case of integration, if the exponent is negative 1, then that is actually ln function. Integrand is ln, and the inner function will be differentiated. After that, that derivative will divide the coefficient. So ultimately we got this is equal to 2 over 2x minus 3 is equal to ln 2x minus 3. Let's go back to our major part of solution. It is, look, I have written here. So we have got that 2 over 2x minus 3 is equal to ln 2x minus 3. Now the question may arise in your mind is, where have we got this 4 as well as 2 from? This is called actually limit. That means when the values of x increases from 2 to 4 with respect to x, the values of x, here it is, this is called definite integration, means the values will vary from 2 to 4, 2 until 4. That's why we will write this 2 and 4, 2 at the bottom, smaller one at the bottom and greater one at the top. So we have integrated the first term. Then the next function is 3x minus 5 and exponent. So exponent is actually key role player. Always we will focus on the exponent. Here exponent is negative 2 over 3. We know that exponent is always added first. If we add, let me add this negative 2 plus 1 equal to what? Negative 1, isn't it? Look, exponent is here negative 2. We have come to know that exponent is always added by 1. 1 is to be added to the exponent. So exponent is negative 2 and we are adding 1. If we add up 1 to negative 2, it is going to be negative 1. So this exponent divides the coefficient. The first and foremost rule, the exponent, increased exponent will divide the coefficient. Our coefficient is here 3. Okay, so 3 is being divided by minus 1. Where have we got this minus 1 from? Just I have explained, it is actually increased exponent. So increased exponent will multiply the divide the coefficient. Then the inner function should be differentiated. If we differentiate inner function, it will be actually 3x. If 3x is differentiated, it will be 3. We have come to know from the previous video while we doing differentiation. So differentiation of derivative of 3x is 3. So this 3 will also divide, because in integration we always divide, we don't do multiplication. Multiplication is done in differentiation and division is done in integration. So first, again I am repeating the word, this one is actually the increased exponent which has divided. Then this 3 is the derivative of this inner function. So derivative of the inner function should divide the coefficient. It's all about division. First we have written negative 1 as the increased exponent, then we have written the derivative of the inner function. Both of them have divided our coefficient. Let's move on to the next step. In the next step, actually we will have to we have come to know that these two, look, these two and these four, these are the limits. These are the actually values of x. We will have to apply the values of 2 and 4. This is the value of x. So first of all we will apply the greater value. Greater value is, I mean, upper limit. Upper limit is 4. So ln, if we write instead of x, if we substitute it by 4, so 4 2s are 8, 4 2s are 8, we have written 8. Then always it will be subtraction, minus my 8 minus 3. Not always, it's actually ln 2x minus 3. So 2 4s are 8, 8 minus 3. Then again this ln, remember this subtraction, this is a clue point. That means here in case of integration, if limit is fixed, if it is of definite integration, then we will have to do subtraction. Upper limit, after substituting upper limit, then we will do subtraction. So upper limit was 4, 4 2s are 8 minus 3, we have written ln 8 minus 3. Then subtraction, then lower limit is 2, so 2 2s are 4, we have written here 4 and 3 unchanged, so ln 4 minus 3. What have we done? First upper limit was substituted, then we subtracted the lower limit, that means value when lower limit is substituted. Same goes here also. Here look at this, let me erase this portion. Let me repeat again. So we will substitute the values. If we substitute the values, we will get ln 2 fours are 8 minus 3, 8 minus 3, then minus ln. Look, subtraction should be done when the limits are given, when the integration is about definite integral. Then ln, this 2 twos are 4, x is equal to 2 actually, okay, lower limit. So 2 twos are 4, 4 minus 3. Let's talk about the next function. In case of the next function, we look at this. If this 3 and 3 are dissolved, it gets 1, and negative negative, it is going to be now plus. So what will happen if we substitute 4 as the value? 3 fours are 12. 12 minus 5, 12 minus 5 is equal to 7. So we have written here 7, and our exponent is, look, we cannot ignore our exponent. Exponent is negative 1. Minus, look, minus symbol should always be used in case of finding the difference between this upper limit and lower limit. Then we are substituting by 2. 3 twos are 6. 6 minus 5 means 1. We have written 1, and this exponent is negative 1. After that, we are going to get ln 8 minus 3. 8 minus 3 is equal to 5. We have written 5. And 4 minus 3 is equal to 1. We have written 1. Then if exponent is negative, it means actually it is denominator. So 1 over 7. It's 1 over 7 minus the exponent. Whatever the exponent of 1 is, it's actually 1. The value will be, ultimate value will be 1. And ln 6 is actually, ln 1 is 0. Ln 1, we know ln 1 is equal to 0. So ultimately ln 5 minus 6 over 7. 6 over 7 means, let me erase this part. If we erase this, sorry, it is ln 5. Then ln 1 is actually 0. Ln 1 is 0. So this is actually 0. Then here, if we do simplification, it is going to be 7 minus 1 is equal to 6. 6 over 7. So that is what the final answer to this question. So what have we learned? It's all about exponent. Exponent should be increased first, then that exponent will divide the coefficient. After that, inner function, remember, inner function should be differentiated. Inner function should be differentiated, derivative of the inner function should be obtained, then that divides the coefficient it contains. Let's solve the next one. I think we will be more clarified from the next solution. The next question has been picked up from paper 060613 slash May June 24. So this is also a question which was set in past paper of add mathematics, and paper was 13. Well, let's see the question. The question is, it's actually similar to the previous one. This is also definite, definite integration, means the upper bound and lower bound of x has been given. So let's write the question. The question is, 0 until 2, 1 plus e raised to 2x whole square dx. Dx is mentioned actually because we are integrating with respect to x. That's why dx is written last of all. Since there is square, I mean whole square above the function, we have just expanded this. So let it be expanded. A plus b whole square, that is a square plus 2ab plus b squared. So a square plus 2ab, a square means 1 square, 1 square means 1. Then 2ab, 2a is 1, b is e raised to 2x plus b square, b is e raised to 2x whole squared. Well, then individually we have written all of them. How did we write? Look at this. This integrand symbol. This integrand symbol has been written 3 times. First with 1, then with second terms. This one is the second terms. Then with the third terms. In second terms, it has remained. Look at this. These two, the coefficient. Always we will isolate the coefficient in front of, I mean before the integrand symbol. Look, because it will be better for us to I mean integrate the terms. So we have taken 1, and 1 ones are 1 actually. This one is 1, and this one is also 1. 1 ones are 1, so that it is helpful for us to integrate. And then these two, look, these two has been written at the front. Then e raised to 2x, Then here there is no coefficient, so we didn't write any coefficient. It's 2 2s are 4. The exponents are double exponents, so it will be 4x. Then how will we do? Let's integrate. Then integration of 1, let's go back to 1. Integration of 1 is actually x. Okay, so this should be remember, because it's antiderivative. Look at this, d over dx of x, d over dx of x is equal to 1, isn't it? That means derivative of x is 1. So as this is antiderivatives, the integrand of 1 should be x. It's very simple. Derivative of x is 1, so integrand of 1 will be x. It's opposite to each other, means vice versa. Well, so it is actually x. We have learned the integrand of 1, any, not any, integrand of 1 is actually x. Then we have written the limit, lower and upper limit. After that, look at this is the 2, this is the coefficient, and we have come to know how to differentiate these, I mean integrate exponential function, not all exponential, in case of e raised to 2 this. So what will happen? First we will integrate this. If we integrate 2x, it will be 2. Differentiate, sorry, if we differentiate this 2x, it will be 2. That 2 will divide. Well, then the function, exponential function, will remain unchanged. Not all exponential function, if it is ln function, actually if it is e raised to 2x. So what will we do? If we are given that constant number e raised to something, then we will differentiate the numerator, I mean exponent. After differentiation, that will divide. Okay, we have divided it by 2, and the function will remain as it is. It will remain unchanged. There is no change to the function. Same goes here also. Look, for the next one, here 4 is our, if we find the derivative, it will be 4. you know different after differentiation, 4x produces 4. So derivative of 4x is 4. That 4 has been written as denominator. We know that always the derivative divide the coefficient, so there is no coefficient, we have written 1. So remember, this 4 has divided here, and this 2 has divided here. After that, the function e raised to 4x, it will remain unchanged. So what have we learned? First we will differentiate the exponent given. In case of e raised to something, in case of e raised to something, simply we will differentiate the exponent, then that derivative will divide the coefficient, and the exponent, I mean the function, remain unchanged. It doesn't undergo any changes. Then these are the limits, lower limit and upper limit. Okay, now look at this, x is equal to 2. We know we will have to do subtraction. Okay, in case of integration, we do the subtraction. After substituting the values, we do the subtraction. So if x is equal to 2, x is equal to 2, it is 2. If x is equal to 0, then it is 0. After that, 2 can dissolve the other 2, it is 1. And here e raised to, look at this, if the value of x is 2, so 2 2s are 4. That's why this is 4x, e raised to 4x. Then if x is substituted with 0, x 2 zeros are 0, so we have written e raised to 0. Then 1 over 4, it's unchanged, 1 over 4. Let's do the same calculation over here. If x is substituted by 2, it is going to 4 2s are 8. Okay, if x is substituted by 0, 4 zeros are 0. Okay, let's move on to the next step. We have just written these two, then 0 is unnecessary to be written, so e raised to 4x. Then we know e raised to 0, that means if the exponent of anything is 0, it is actually 1. So e raised to 0 is actually 1. Not only e raised to 0, but also for any number, if exponent is 0, the value is 1. So we have written here 1. Then what about this one? We have just isolated this, 1 over 4 into e, that means this has been written over here. Then the e raised to 0 is 1, we have learned. So 1 over 4, 1 over 4 into e raised to 0 means 1 over 4, 1 into 1 over 4. Then ultimately what are we going to get? E raised to 4 has been written first. Then this e raised to 8 over 4. This has been written over here. After that, we have simplified the constant numbers. It's 8, 4 2s are 8, because if we multiply this 4 by 2, it is going to be 8, minus 4 ones are 4, and 1 is 1. Ultimately, what are we going to get? A raised to 4, then it is also unchanged. Then if we do subtraction, it is going to be 3 over 4. Ultimately, this is our final integration. So they told us to leave at this stage. We can extend and expand this, but the question told us to leave as the exact form. Look at this. This is an instruction. It should be left in exact form. That's why we have left at e, because we know e is an irrational number, and which can be actually simplified more, but we will not do because there is no further instruction for writing more. So we have understood. What have we understood? If there is any exponential function, not all exponential function actually, if it is about e raised to something, suppose e raised to 5x, let it be written as e raised to 5x. So what will, and here there may be 2 as coefficient. What will we do? We will differentiate this exponent. After that, it will be, this 2 is unchanged, this 2 is unchanged, this 2. Okay, then after finding the derivative of 5x, we will divide. Then this function, this function, exponential function, will exactly remain unchanged. That is how we have found the integration of this question. Let's move on to the next question. This question has been chosen from a paper 9709. Look at this, 9709 slash 13 major 24, means it's an A level question paper, a pure mathematics one. So code is 9709 slash 13, and the number of question is, it is question number 9. The question number 9, we are going to solve this. Let's see what is written in the question. Question A is, the diagram shows the curve with equation y is equal to square root over 2x cube plus 10. Find the equation of the tangent to the curve at the point where x is equal to 3. So they told us to find actually tangents, equation of the tangent. So equation of the tangent, actually such question belongs to derivatives or differentiation. As this is not our topic to be discussed, we are dealing with integration. So we will move on to the question number B. Let's see what B says. Yes, B says the region shaded. Here is the question. You can see the region shaded. The region shaded in the diagram is enclosed by the curve as well as the straight lines x equal to 1 and x equal to 3 and y equal to 0. That means whenever the question asks for finding the area, they told us to find the area. Okay, actually the question asked us to find the volume of the shaded region when it is rotated about 360 degrees about x-axis. And so whenever the volume, for some reasons I cannot show you the later part of the question, it has been erased unexpectedly. So the clue what is, actually we will find the volume. Whenever volume or area under a curve is to be obtained, we will integrate. So let's start the integration. If it is about only area, then we write integration of y, actually function, just integrating the function. But whenever the word volume is mentioned, here volume we are finding for a volume. So for volume, the formula is actually pi integrand y square. Remember, pi is to be included in case of volume, but if it is only area, there is no necessity of pi. And for volume, we will find y square. Okay, integrand of the square of the function. Let's see what it is actually. Our function was actually y was 2x cube plus square root under square root over 2x cube plus 10. Then we have written square. Let me show you the function. This is our function. This is the function actually. Y equal to square root over 2x cube plus 10. Then we have just written that one, the same function over here. We have written the function. Then this square is for actually volume. Whenever volume word mentioned, then we use whole square. Then what happened here? Square and the square and square root, they dissolved each other, so there is no more square, neither square root nor square in this case. Well, then where have we got this one? Look, this one as well as the lower limit as 1 and upper limit as 3, where have we got this from? Let's see what is the limit actually. Look, limit is actually lower limit and upper limit are the actually values of x. So look at this values of x. This is our shaded region. Shaded region is this, where the lowest value of lower value of x is 1 and upper value of x is 3. So these are the actually limits. Limits are fixed and dealt in this way. We have written 1 as the lower limit should be written at the bottom and upper limit should be written on top. That's how we have written that the limit is from 1. Here is 1, this is 1 and upper limit is 3. So our function have been turned, the function has been turned to when square and square root cancels each other. This is actually our function. Okay, this is actually our new function. Now we are going to integrate this. Before doing final integration, what do? We isolate them. Look at this, they should be individually be written. We have written this part individually. It is actually 2 pi then x, because we are actually integrate or differentiate the function, the variables. That's why this constant 2 pi, this is unnecessary, so we have left it at the front. Then this function plus 10, plus 10 and pi into 10, so 10 pi, it's actually 10 pi. And what are we going to integrate? That is 1. 10 pi ones are 10 pi ones are 10 actually, so it can be written as 10 pi into 1. Let's start integrating. For integration, again we are going backward, and we know that it's all about the exponent. So exponent is what? This is 3. Look at this, this exponent is 3, which will be increased by 1. If we increase it by 1, it is going to be 4. That 4, and we know that 4 will go down, so we have written 4. And 2 pi, this is unchanged. So exponent, increased exponent will divide the coefficient. Then what will happen? This degree of x is going to be 4, and there is nothing else actually. So we have written x raised to 4, and our limit is from 1 to 3. What about this one? Here actually there is no variable, it's a constant number. And in the previous solution we have come to know that for constant number of 1, 1 is equal to integrand of 1 is equal to x. Okay, and 10 pi, it is unchanged. Let's see what it produces in the next. If we cancel out these 2 and 4, it is going to be actually 2, so pi over 2. In the next step we have written here pi over 2. Okay, pi over 2, then x raised to 4 is the function, and the next function was x. Now what will we do? We will just substitute it, we will substitute this function with x coordinate. So x coordinates, if x is 3, it is going to be 3 raised to 4, because exponent is 4, minus. And remember, we should not forget that there is a difference. We should find the difference between these two values. So when x is 1, so 1 raised to 4 plus 10 pi, then x is actually 3, first upper limit 3 minus lower limit. So what is it going to be? 3 raised to 4 is actually 81. 3 raised to 4 81, and 1 raised to 1 is 1 raised to 4 is 1, plus 3 minus 2. 3 minus 1 is actually 2, so 2 tens are 20, so it is going to be 10 into 2. Well, then from 81, if we subtract 1, it is going to be 80. 80 divided by 2 plus 2 tens are 20. After that, what are we going to do? If we divide this 40 by 2, it is going to be uh, 80 divided by 2, it is going to be 40. So 40 plus 20 means 60 pi. So 60 pi is our answer, final answer. And you can find it. If you want to write more exact answer, it can be written in decimal format. up to three digits, I mean three significant figures. So it is going to be 188.5, not three significant figures, one decimal point. So 188.5, which can be written as 189 if you round it up to three significant figure, 189 units square. So what have we learned from here? We have learned that whenever volume is to be obtained, then we will multiply the whole function by pi, then we will integrate the function square. Okay, not only the function squared of the function will be integrated. Okay, so we have done so. I think you have understood better than the previous one in this case. So let's solve one more problem. This question belongs to paper 970912 slash May June 24. So this is also an A level question. Let's see what the question told us to do. The question says that this is actually part B. Part A was, I think, different or differentiation, on the basis of differentiation, as the differentiation is not the topic of ours today. So we have skipped number A. It was done in the previous video. So B says the diagram shows the curve with equation y equal to this, and this is the curve show, this is one curve, another one, the line AB and the line AB. Okay, it is given that the equation of AB is this. So both of the equations have been given, one is of the curve, another one is of the line. Now you have I think already come to know that for finding the area, shaded area, we require the lower bound and upper bound. So here for lower bound of x, actually in question number A the solution is available. When we found the differentiation, or just they are intersecting, the line and curve are intersecting each other. So finding intersecting point, we got that this is actually 4 at this point. At A x is 4, at B x is 16. So this is our region which is to be calculated. So lower bound is 4, upper bound is 16, because we have already come to know for finding area or definite integration we require the lower bound and upper limit. So lower limit is 4, here 4 and here 16. In the just immediate previous question, we have written pi as well as y square. That was actually for volume. This is not about volume, this is simple area. So simple area means we will have to find out just integration. We will have to integrate the function. First we will write area under the curve, because there is a curve as well as a straight line. One after the other we will find the area under the curve. Let's see, area under the function of area curve is this. Look, function of the curve is this. So we have written here, and the limit we have, I have already explained that limit is from 4 to 16. Okay, so 2x minus 8x raised to half. We can isolate, look at this, it is uh, integrating by parts is more convenient. That's why we will individually write them. First we will write 2x, then we will write 8x raised to half. We have written so. And 2, the coefficient, numerical coefficient or constant number is always written at the beginning. For the first one we have written 2, then the second one 8 has been written, because here coefficient is 8. 8 has been written and kept outside, and this is our function which is to be integrated. And you may ask one question about this red line. Okay, that modulus symbol, I am going to explain the modulus symbol later on. Let it be over here. First of all, let us continue. uh, okay, let me tell about this modulus symbol. Modulus symbol is for, actually, look at this. If we look at the curve, look at this curve is under the x-axis, isn't it? This is the curve, this is curve, and it is under x-axis. If the curve or any area which lies under the x-axis, it produces negative value. So we are searching for area. Area can never be negative, but as it is lying below the x-axis, it will produce negative value, which we will suppose it to be positive. That's why we will use modulus symbol. I think you have understood the reason behind using this modulus symbol. So we have used this modulus symbol because it will actually produce negative value since it is lying under the x-axis. Well, start doing the integration of the curve. First, what do? We just look at the exponent. Here exponent is what? 1. It's all about exponent, exponent is here 1, and we know exponent should be increased by 1. If it is increased by 1, it is going to be 2, and exponent will divide their denominator, coefficient. So 2 has been divided by this increased exponent. Then the function, what is it going to be? It is going to be 1 plus 1 x squared. We have written the limit, as you know how to write. After that, here exponent is half. If half is added to 1, it is going to be 3 over 2. So we have written here 3 over 2 under this exponent, coefficient. So under the coefficient, the exponent, increased exponent, we know increased exponent will divide the given coefficient, or actually the exponent will divide. Increased exponent always divides in case of integration. Well, so if the function is integrated, it will be 3 over 2. Already we have come to know half plus 1 is equal to 3 over 2. Then if we cancel out this 2, it is going to be 1, and the upper limit of x is 16, so we have written 16 square. Lower limit of x is 4, we have written 4 square. And in between them there will be minus. You have not forgotten that in case of integration we should do subtraction. Then this symbol is negative. After this, if we simplify this composite fraction, it is going to be, this 2 will go up, this 2 will go up, the denominator, lower denominator. So 8 into 2 over 3, this will go down. This is actually reciprocal in case of fraction. And x is, upper limit of x is 16 raised to 3 over 2, and lower limit of x is 4. We have written 4 raised to 3 over 2. So 16 square means 256, and 4 square means 16. We have written here 16 over 3. Then this 16, look, this 16 can be written as 4 square. Look, we have written 16 is equal to 4 square, and this is unchanged exponent. And 4 can be written as 2 square. 4 has been written as 2 square, and this exponent is as it was. So from 256, if we subtract 16, it is going to be 240, and 3 over 16 unchanged. And these two, the exponent, these two can cancel out each other, so there remains 4 cube. 4 cube means 64, and same goes for here also. So 2 cube means 8. If we simplify this, it is going to be, it has been written just beside this. Let me show you. It is 240. The first constant number is 240, and if we multiply this, this is actually, what is it, 64 minus 8. 64 minus 8 is 56. So 16 has been multiplied by 56. We have written here 16 into 56. After simplification, we will get 720 minus 896. What is it producing? Look, as I have told in the beginning, it is producing negative value. And what is the reason behind this? And whenever any curve lies under the x-axis, then it produces negative value. But we require positive value because area is a practical quantity which can never be negative. So it's 176 over 3. If we write it, it is going to be 170 over 3. Okay, this is not the area of the shaded region. If we go back, they have told us to find the area of the shaded region. Area, look at this here, area of the shaded region. Shaded region is this portion. This portion is the shaded region. But what have we found? We have found the area under the curve, means all of this portion. Okay, so what can we do from whole this area, obtained area? If we subtract the area of this portion, this is actually triangular stage. Okay, there are two ways to find the area of this portion. One is integrating the function of the line, equation of the line. Another one, simply we can do this. This is a triangle, we will find the area of this triangle. I think it's simpler and better. That's why we are going to find the area of the triangle. Because look, once again I'm repeating, they didn't tell us to find every area, that means whole of the area. They told the find to find the area of the shaded region. Shaded region is lying between the curve as well as the straight line, and the area what we have got is actually this portion starting from here to here of this curve. And from this, if we just subtract the area of the triangle, then it is going to be our required area. So let me erase this portion. Well, how can we find the area of this triangle? It is actually area of a triangle, we know half into base into height. If it is a 90-degree angle, this is actually a straight vertical line. So half into base into height, base into height. Okay, so how much is our base actually here? Base starts from here. Look, this portion is our base, isn't it? So it starts from 4 to 16, means it's 12. Base is our 12, and height is this length. This is our height. Height is how much? Already we have decided. It is actually in the previous question we have learned that it is the point was -8. It is not available in this question, but in the previous question we have solved that it was -8. Point is -8, means height is actually 8 units. So our base is 16 unit and height is 8 unit. So ultimately it is going to be 8 12s are uh, 8 12s are how much? Not 8 12s, 8 16s. Sorry, not 16. From 16, if we subtract 4, it is going to be actually 12. So 8 12s are 96. 96 divided by 2, it's 48. So area of the triangle, this portion is actually 48. I have written over here. Let me show you. It is over here. Area of the straight line, area of the straight line, half into base into height. Height is 8. Again I am telling that 8 is actually how had we come to know that this is 8? In the previous question, while finding the intersecting point, we found that this is -8. For x it was 4. For y y coordinate was -8. That means the length of this side is 8. So we have written base is 16 minus 4. 16 minus 4, I have already told it's 12. 12 into 8. So 12 into 8 means 96. 96, half of 96 is 48. So 48 is the area of the triangle. Already I have explained that area of the shaded region means from whole of this area covered by this curved line, we'll have to subtract the area of the triangle. So area of the curve we have got 176 over 3, and area under the straight line is 48. If we do subtraction, we will get 32 over 3, which can be written as 10.7 in decimal format, which is called in three significant figures. So what have we learned from this one? In short, if curves or straight lines are given like this, look, let me erase this first. So if from the previous question we have come to know that this is actually 4 and -8. Well, then this one is 16 and 0. Well, after that we have just got how much is this distance, I mean area. We have got the area before this, above this curved line. Then we have subtracted the area of this triangle. Area of this triangle has been subtracted from whole of this area. Then we got this the difference in between them, that is this shaded region. Well, now one more question you may ask, that in case of curved line we have applied integration format. I mean, we did integration. Why didn't we integrate that straight line? Because there is an equation for this straight line also. Look at this, the straight line, the the equation, look, the equation for the straight line also has been given. Why didn't we integrate this? Actually it's all the same. If we integrate this function, we will get 48. Let me show you. It's y equal to, I will have to move on to the next page. It's 2x minus 32. 2x minus 32. Okay, so 2x minus 32 over, let me see what was it, over, sorry, over 3, yes, over 3, over 3. So 2x over, we are integrating this, and it is actually from 4 to 16. Let me erase this unnecessary line. If we integrate, look at this one third, okay, this 3 can be isolated, we will write over here, and this is our function, okay. If for this function we can individually write them, 2x minus 32, this one, and minus one third, and that is 32. 32 can be written. After that it is going to be, we can use the integration symbol even here. Suppose this is integration symbol is 1, okay, and our limit says 4 until 16, 4 until 16. Here also we can write the integration symbol, limit is 4 until 16. Let me show you what is it going to be. First this half, okay, what will be the exponent of this is going to be, it's already 1, so it is going to be 1 over 1 plus 1 means 2. These 2 will divide this, okay, and the exponent, I mean function, is going to be x square, okay, and it is 4 until 16. What will happen to this 32? Oh sorry, it is minus symbol, I have written two symbols. It will be minus 32 over 3, okay. Then what will happen for x, I mean for constant digit, it is actually x, okay. So it is x, and our limit is 4 until 16. Let me write over here using different ink. So what is it going to be? 1 over 4, okay, and here x square means x, the value of x is our 16, so 16 square means 256. From 256, if we subtract 4 square, let me write it, 16 square minus 4 square, okay, and then minus here 32, 32 minus 32 over what, 32 over 3. Can I move to the right side? Let me clarify is in another simpler way. So it is going to be the one third, okay, this one third will be shared by both of them. This is 2x, and this is one third, that means 32 over 3, and here our exponent, I mean our function is x, here our function is 2x. So these two can be written, these two can be written over here, okay, and our here limit is what, from 4 to 16, okay, and 4 until 16. So what is it going to be? Here power is going to be 1 plus 1 means exponent is 1, it is 1 plus 1 means 2, so it is going to be 2 3, and these 2 will go down, and the function is going to be x square, okay, and our limit is from 4 to 4 until 16, and it is 32 over 3. Then what about, this is not x actually, this is 1, okay. So for 1 our integrand is x, and it is 4 until 16. If we substitute the values, corresponding values, so it is going to be 2 over this 1 over 3, and this is going to be 16 square, okay, 16 square minus 4 square minus 32 over 3. Here it is going to be 16 minus 4, 16 minus 4 equal to 1 over 3, it's 256. 16 square means 256. From 256, if we subtract 12, it is going to be 244 minus, it is going to be 32 over 3 into, it is going to be 12, okay. Let me go downward. Sorry, it should be 40. How? 16 square means 256. 256 minus 16 means 240. So it is going to be actually 80. 80 minus, here it is going to be 4 threes are 12. So for its 90, how much? Negative 128, negative 120, negative 128, and ultimately it is going to be negative 48. But I you can remember that I told, whenever any we find the area under anything, any x-axis, area of any equation or any function under x-axis, it will produce negative value. So we will accept the positive value considering it above x-axis. So actually the area of the triangle is 48. From 48, we, that means we have subtracted this 48. Okay, here we have subtracted 48 and we got this. So what have we learned from this integration? I tried my level best to make you understand. So if you have understood something, it will be, all my efforts will be successful, and I will be grateful to Almighty Allah. Allah Hafiz. In the next video we will solve something else.